So yeah, morning everyone. It's really great to see the whole room here in the morning. Yeah, cool. So we're gonna talk about the C++ ecosystem here. As a disclaimer, so like I'm from JetBrains company, you can probably guess from my t-shirt. But I'm not gonna talk about JetBrains tool at all here. If you're interested in JetBrains tools, come to our booth and we can tell whatever you're interested in. So this is not a talk about the tools, and this is not a talk about the JetBrains tools. This is a talk about the ecosystem and what we have here and what we can hope here for. So you can find me in Twitter. There is a Twitter handle here if you're interested. And so, just before we start with the agenda, just a few words about myself. So I'm working in JetBrains as a product marketing manager for all our C++ tools. Before that, I spent 8 years in C++ development, mostly on Linux, doing some embedded stuff and some networking protocols. So some low-level C and some crazy C++ with all the function pointers. So yeah, after that, I moved to some non-that development probably positions, so doing some kind of developer advocacy and some marketing and some product management around our tools. I do run a C++ user group in St. Petersburg in Russia, so if you're by chance there, you're all very welcome, and I will be glad to have some new faces as attendees and definitely speakers, so just ping me and I can organize a meetup for you as a speaker if you're in St. Petersburg. So the user group is actually quite big. We have 1,500 registrations there, so and I can set a meeting like easily with 100 or even more people there. So we're actually quite crazy, and we have very big C++ Russia conferences, so you're also very welcome to come. So we actually love C++ in Russia. So here I'm going to talk about the, as I said, C++ ecosystem. So what exactly we're going to cover here? So first of all, I plan to overview the current state of C++ development, using some information I gathered from different sources, surveys, and various sources, independent sources. We'll explore how language features and techniques are used across different areas, the top areas popular for C++, top 3 areas to be more correct. I will talk about which are they later. And we'll try to identify the key evolution paths in that area and to see how they are related to the general trends in the C++ community. So we'll also check how developers use unit testing and code analysis techniques just to see if that helps their transition into the newest standards and if that supports the transition. And we'll discuss how the current language evolution actually addresses our needs and how tooling and C++ committee can help collaborating with all the people in the community. And yeah, the general disclaimer is that I might be wrong here, because you know the statistics is always wrong, and I also might be wrong here. So you might have a different opinion, so if that's the case, just raise your hand, shout out, that will be really great. I like discussions. The data which I'm relying here is mostly taken from several sources. So the biggest source for the data here is the State of Developer Ecosystem Survey. We run it by JetBrains for 3 years in a row already, so 2017, 18, and 19. 2017 and 18 results are already available, so if you search for developer ecosystem JetBrains, and there will be, in the very end, there will be the slide with all the links, so you can just take a photo and grab all the links I will be referencing here. So the results are available. 19 is still under processing, so I hope it will be available quite soon online. So the survey is closed already, we're just processing the data. And I will try to explain why we actually do that for such a long time, the processing. So in general, this year we collected 15,000 respondents' replies. And the respondents, partially they are our users, because we do spread the survey using our internal channels, like connecting to our users, connecting to our site visitors, connecting to those who do subscribe to our news. But we also try to remove this kind of bias, and we do promote the survey using some ads in Twitter, Facebook, and Google AdWords. So we do believe that there is some data which is not connected to JetBrains. We actually try to limit the JetBrains branding in the survey to the minimum so that the people actually know that they're filling our survey, but they're not like filling the pages which is filled with our branding. So I can say that we actually, when we started in 2017, we didn't have that many respondents. Now we're actively growing, so more and more people are actually filling the survey. And there are more people filling the survey who are not connected to JetBrains, so who doesn't know about us a lot. So maybe you've heard something about us, but mostly they came from some external channels. So also to avoid some data bias by the English-speaking countries, we do translate the survey into 6 languages, so that the people, for example, from China could fill the survey, because the Chinese people usually don't get English that good, so they usually don't fill the English surveys. And in general, the position about the countries is that from different sources and different surveys, we know that there are a list of countries which actually covers 70% of the developers around the world. And our goal is to cover all these countries which do cover the 70% of the developers, so that we have the best representation. Also, we perform the weighting for the data, and that's the longest processing part. That's why it takes so long this year. So the data that I will be showing here is not weighted, because I process it on my own before the research department actually process it. So the weighting is, the purpose of that is to actually limit the differences in number of students, developers in various countries, and so on and so forth. So we need some weights to make that data less biased. So yeah, to have some more particular numbers on what we do collect around C++. So for C++ pods, so we have C and C++ pods separately in the survey. So those who use C or C++ in the last 12 months, so 1 year, it's like 5,500. Those who used C is like 3,500, C++ it's like 4,000. And there is this number, primary C++, which is 1,500. And this is the very important, this is the data I will be relying on, because we have a question like which languages you used in the recent year, and what are your primary languages, and you can select only 3. And this is the most important, because those people who do select primary C++, that's mostly the professionals who work in C++ or who use it nearly every day, and who is actually our audience. And the second reason is that these are the only people who do fill all the questions on C++, because that's they have to do that if they select C++ as a primary language. So I'm not relying on those who just used occasionally C++, because that might be different from case to case, but I rely only on the primary C++ data. I guess there was a question, yeah. Yeah, so primary C++ is those people who said that they use C++ as their primary language. Total number of those who use C or C++ is those who marked, you mean the participants, because we cover all the languages, all the technologies. So that's not only C++. There are people who are using only Java or PHP or whatever. So the 15,000 is the total number of respondents who filled the JetBrains ecosystem survey. So, but definitely not all of them are using C++, unfortunately. Yeah. So those who used at least C or C++ at least several times during the last year, that's just 5,500. So, but yeah, we are mostly focused on that group of 1,500. I would say that in 2018 we got more, we got 2,000, but then the GDPR policy happened to us, and we had to clear all the databases, and that actually reduced the numbers for us. So yeah, that was painful, but still, we're recovering. There is another survey which I will be using and comparing here, especially in terms of C++ standard usage, and that's the developer survey run by C++ Foundation. They did it in 2018 mostly. That was the most extensive research. And the number of respondents who used C++ at work was nearly 3,000, and some hobby and some hobbyist developers as well. So, and the good thing is that in that survey, more than half of the respondents used C++ for more than 5 years. So I guess those people who filled the survey on C++ Foundation side is mostly that targeted group of people closer to the committee, those who use in C++ for longer years. So they are maybe more profound in C++ than just the general audience. Yeah, so just to understand how we are distributed among the platforms in the C++ part, so just to understand how the data is actually distributed, so most of our audience is on Windows and Linux. Mac is just the less popular platform there, which is more or less like expected for C++. And also there are quite a big number which are using like 2 out of 3 platforms, and that's mostly like, again, Windows and Linux. So the most 2 popular platforms for C++ development. I would say that Mac usage is mostly goes to game development, which is naturally Windows and Mac. So they're mostly not on Linux. And actually this data is completely confirmed by our tools usage. So when we see how our tools for C++ are used across the C++ community, we see nearly the same distribution. So the less popular platform is Mac. Yeah, so now some areas. So this is a little bit strange question. I don't like it very much because, yeah, I guess on your slides, not all the not all the data has some names. So like the first column is embedded, the second one is games, the third one is libraries and frameworks, the fourth is mobile, then comes desktop, this high pike, then machine learning and some web backend and front end. The thing is that in developer ecosystem, we try to keep general questions the same across all technologies. So sometimes we have some strange areas here for C++, like web, back, and front end. I'm not sure what people were meaning while filling these areas for C++. We never know because the whole survey is anonymous, so we anonymize the data. So, but since we have the same names for the areas across all technologies, we have to do that. And I actually don't like this distribution mostly because we lose financial and banking as a separate area here, which is very important for C++. We'll talk about it later. Yeah, and this is actually important because this is the employment status for those who fill our surveys. So most of the people are fully employed C++ developers. And that's important because what they use is what makes the market right now. And the second biggest group is students, and what they use is what will make the market tomorrow. This is also very important. And actually the data that I will be showing, it's different from one group to another. The other groups are just too small to talk here about it all. Yeah, so C++ standards. There is this slide called throwing a ball. So actually, I guess Bryce yesterday asked already, so but I will try to do that again. So who's using the C++ 20 here? Come on, be brave. Yeah, Adi, I know you're brave. C++ 17. Cool, great. 14? Yeah, 11. Okay, so under 11? Yeah, still some people. Cool. Yeah. What we got from the developer ecosystem survey looks quite similar to what I've seen here. We don't have here C++ 20 because when we were preparing the survey, we usually not put in the standards which are not officially signed. So I guess I will try to put 20 for the next year just to, because I'm interested. Breaking this kind of rule. So, and we also do have separate comments for 98 and 03, which probably is not that logical because that's nearly the same standard, just some bug fixes in 03. So yeah, the story here is that we still have some people on the pre-C++ 11 standards. C++ 11 is still dominating. I would say that while I was submitting this talk for the very first time, I did it once before Core C++ at ACCU conference, and I sent the submission back in fall 2018, and I was not expecting these big numbers for C++ 17. I was not that optimistic, actually. I didn't have them at that time, and I was expecting less. So like 35%, nearly 46, actually makes me very happy. I would say that's actually great. And I would say that C++11, when it was introduced, it was like a breaking change for the whole C++ committee. And there are people who, and the whole C++ community, sorry. And there are people who now consider C++12 to be the next step like that. And I really hope it will be like that, because it's full of nice things that we can move to. So we'll see. Here with this actually picture, there is a nice story. I do participate in several program committees for different conferences. And recently we had C++ Russia conference when I'm also in the program committee. And we had a very nice joke, like after discussing a huge bunch of talks around C++70 and C++12, as we said, and now we're back to our real work with C++98 and C++03. That's somehow how the things works for us, so we do still work a lot on C++12, and I will try to understand where this all comes from. Yeah, so, sure. Yeah, exactly. So good command, actually, I forgot to say that. So the people could choose more than one, because that's normal. They can use several standards for different projects. So they could be more legacy projects, they could be newer projects. We've heard about asking them to choose the primary one, but sometimes it makes a difficult choice. I know that because usually on the iPad we're running on the booth, we're asking for the primary standard, and it makes people think for like 5 to 10 minutes what is the primary standard they're using. So we actually allow them to choose more than one, because we think that's more fair. Actually, I guess more than half usually just choose one. So that's fine, but there are quite many people who choose two, usually they are close. Yeah, so just to compare with the previous year. So that's what we got a year ago, and it's somehow very similar in terms of C++11. C++14 and 17 is growing, and that's really great, because the growth of C++17 is quite big. We're not expecting this big growth. And I will show later, we do ask people every year if they plan to migrate to the newest standard in the next half year. And we were expecting from the last year, we were expecting about 8% migrating to C++17, and here it's more. And yeah, some decrease in C++98, C++03, but still quite many people there. Yeah, so just to compare with what the C++ Foundation got here a year ago, so that's the C++ Foundation survey on the right for C++ standards. So yeah, they have quite many people who felt that like, yeah, maybe it's not that good to write the colors. So green for C++ Foundation is, yes, I'm using pretty much all the features from the standard. Yellow is no, the standard is not allowed at all. And blue is standard is allowed partially, so just a few selected features. So you can see that C++17 was mostly not allowed for the people, so just some people who used partially, and like some number of people who were allowed to use the standard, and other standards were mostly allowed. And yeah, like I guess that when the C++98 is allowed, sometimes that's not a problem for like having C++11 and higher standards. So the people try to use the biggest standard that is allowed. So that's fine that there are quite many people who are allowed to use older standards, because mostly older standards is always allowed. But it's actually nice to see that some people are not allowed to use older standards. Hopefully because they are moved to the new standards. I do hope for the best. Yeah, one more interesting picture is that when we started our C++ tools several years ago, we also conducted some kind of research on how the people use the C++ ecosystem, how they use the standards, how they use the tooling, because that was important to start the tools and to know what to target. So, and we got this nice picture. We were quite naive at that point, so we just gathered all the C and C++ standards into one question. We don't do that now, so yeah, but at that time we got like the estimation for the C++ developers in the world, which was 4.5 million of developers, which was confirmed later by some other independent surveys. So I do believe that the data we collected at that time was more or less correct. So, and it's interesting to see that like C++ 98, which was 13%, just nearly stays the same 5 years later. Yeah, and C++ 11 obviously grew from 34 to 60, just because that survey was mostly conducted in 11, 12 years, like in C++ 11, C++ 12. So that mostly was the time when C++ 11 was introduced and actually started getting more popular. Yeah, that just some nice picture for the reference. Yeah, now let's try and, so I've showed you the distribution for the standards. Let's now try to analyze if there is any connection to the platforms, compilers in use, or area of development among this distribution, and if it actually differs or is the same. So, yeah, we'll look at these groups. Okay, so standards per platform. So the first group is Windows, the second group is Linux, and the third group is Mac. So you can see that distribution is very similar here. So they all have like the same pikes. Like Mac is a little bit less in terms of C++ 17. But like in general, they're mostly the same. So I don't see any big differences between the platforms. So most of the platforms just go on the same way. So compilers, also very similar. So there are still some smaller differences, like Clang is a little bit better in terms of C++ 17. But in general, yeah, the compilers right now, they try to support the modern standards nearly on the same speed. So they try to be on top of the standard as soon as they can. There might be some still issues with C++ 12, which is like big and huge for the compilers, and it's not obvious for the compiler people how to implement some things. If you probably know, there is this working group in the committee, which is still, it's created especially for tooling people. There are quite many compiler people who are now discussing how to deal with modulus and how to compile them properly. There are huge discussions, so that might slow down the adoption of the C++ 20. But in general, the compilers during the recent at least 5 or 6 years, they are adopting the features more or less nicely. So they try to be on top, they try to implement the TS and to have some special options for the new features so that you can actually try them before they even in the standard. The problem happens is that then some compilers do implement some older version of the standard, and then we accept the changed version. That's what happened to the concepts, because the concepts, like there is just in parallel, there is another talk on the Clang concept. I'm wondering what is happening there, but I can't go and listen. But as you probably know, in GCC there is the -f concept flag, which implements non-standard thing. They do implement the concept that was like introduced several years ago, and they're not compatible with what is currently accepted to the standard. So with the current features in C++ 12, we do have some issues with the compilers, because the GCC actually need to change the implementation, and the Clang need to do some implementation. Yeah, and there is also Microsoft compiler, but I guess like Steven Lavavey will be on top. He's done actually an amazing job in that sense. Yeah, so but in general, yeah, for now it looks like nearly the same. Yeah, some areas distributions. So the things that's interesting to me here is that naturally embedded is like mostly on C++ 11 and pre-C++ 11. C++ 17 is less popular in the embedded area. And we'll talk about this area in details a little bit later, so you can see some trends and identify them. And yeah, libraries and frameworks are leading in terms of the C++ 14 and 17. And this is also like natural, because when you start a new library, you can do any standard. Like if you're not dependent on some legacy code and some legacy library, why not to start a library on a US standard? That's fine. Like you would like to play with some code, why not to do it nicely? So yeah, libraries are mostly fine for people to start with the recent standards. Distribution per employment group. And yes, so the two most interesting groups for us here is full employment, partial employment, like we can join them together, and students. So obviously, like those who are full employed, they are not that probably brave because of the legacy code. They still have to use older standards, so C++ 11 and pre-11 standards are dominating for them. And students, like they can use whatever they want. If like we're teaching them in a good way, they can use newer standards. So they do that. They actually use in C++ 17, 14, 11 quite actively. So when you see that the first group, which represents the students, is quite updated to the new standards. And that's fine, because these people will later come to the industry, and hopefully they will continue using the new standards until, like, at least when they can. So there could be still some legacy code, but at least they are prepared and they are taught to use the new standards. Yeah, and just again about the employment groups. So this is how these two employment groups, how the standards usage is distributed for these two biggest employment groups. So you can see that, like, yeah, for students, like mostly it's C++ 7, and this is quite a big group in C++ 17. And if we talk about like older standards, pre-C++ 11 standards, obviously like these fully employed people are mostly getting these two groups. Okay. Yeah, upgrading. Yeah, let's again just try and do this throw in a ball thing. Who actually plan to move to C++ 17 or C++ 12 in the next, let's say, year? Cool. Cool, you'll learn amazing world. Yeah, great. Let's see how the people are planning to move. Plans to upgrade. Good news, nearly 40% of the people are willing to upgrade to C++ 17. Bad news, 33% not planning any upgrade at all. That's like the picture we see for several years in a row, just with different numbers. I'm glad to see that the number of people who are actually willing to upgrade to C++ 17 is growing. And that's a natural probably process after the standard was signed, but it's still good to see. But it's kind of disappointing to see that not many people are going to upgrade at all. But yeah, let's see some more interesting picture. Let's see how this is distributed per the current standard they are using. So, like, obviously, like, because we do not ask about C++ 12 in our survey, C++ 17 is not moving anywhere, at least from our survey. Hopefully, they will be moving next year when I add a C++ 12 to the option. Quite obviously, again, that the people who are closer to C++ 17, they're probably easier to move to newer standards. So if you're on C++ 14, you might be better prepared for C++ 17, so there are more people willing to upgrade. If you're on older standards, you're more about the legacy code, and it's kind of difficult to update to a newer standard. And that's what we actually see here. So probably quite an expected picture, but still kind of interested on how this is distributed. And yeah, it's still interesting to see some pikes of people still trying to move to C++ 11 from some pre-11 standards. They are still willing to get to the newer world. Hopefully we'll get there. Okay, so areas. What are the top areas for C++? Let's again check the audience. So how many of you here work in different financial, banking, or trading systems? Okay, games development? Oh, cool. Embedded, my favorite area. Yeah, I love these people. I was working in the area, that's why it's my favorite one. But yeah, these are actually the top 3 areas for C++. So this is confirmed by several researchers, so that's what we know for sure, that these are the areas where C++ usage is like the biggest, and this is the most popular language there, and this is kind of obvious areas for C++. And I don't think these areas are going to move from C++ anytime soon to any other language, because they have reasons, and we'll now discuss them. Yeah, let's take a closer look, and we'll start with banking and trading, one of the biggest area for C++, and I would say quite modern in terms of the C++ usage in comparison to other two. So they still have modern C++, they still have language choices, they just have different, like, as we discussed yesterday, and I do believe in that you need to use the language for your tasks, so there are different tasks for different languages. So in banking and financial area, there are still several languages used, so Java is still used for some enterprise systems, backend trading platforms, C++ for low latency, high performance stuff, C# for front end and desktop, and Python for all types of different scripting that exist. Currently, there are probably more scripting languages competing with Python in that area, because like we have Go, which is kind of competing in the scripting area, and some others, but Python is more or less the most popular choice. C++ is a primary choice if you speak about the low latency and high performance. And when you actually speak about the high performance in financial area, you speak about the low latency. So that means just the same for financial people. So yeah. There was a nice talk at CPPCon in 2017 by Carl Cook, which was called "When a microsecond is an eternity, high-performance trading system in C++." He was actually explaining in quite a good way how the trading and financial systems works and why they do care about the low latency. And he actually explained the goal there quite good. He said that the tire deviation is more important than faster median, because like, if you're successful 4 times out of 5, you lose in trading or in financial area. You have to be successful 5 times out of 4. And that means the tire deviation. So the median is not that important. And the problem is that operation system, networks, hardware, and all the standard tools, they're mostly focused on throughput and fairness, not on this low latency and tire deviation stuff. So the real challenge for these people is to understand the compiler output, to understand what it's actually generating if they're using some standard compilers. And like, no wonder, Compiler Explorer, the tool to understand the assembly output created by a person from the trading world, Matt Goldbelt. So he started the tool because he actually needed to understand what he has in the end after he compiled his trading code. And he needs to read this assembly code. And that's what people in financial and trading area does a lot. And these people, they actually, when they are in the committee, what I can see for now is that they are the best advocates for the C++ principle, don't pay for what you don't use. Because that's the biggest matter for them. So yeah, a little bit more about how they use the C++. So allocations, this is a subject very important to them. So they have a pool of the pre-allocated objects. They reuse the object instead of the deallocating the object, because deallocating is very expensive. Reusing is much better. That's what they do. And Carl, in his talk, he explains that in like many details. You can like check it out. So templates and like exceptions are fine if they don't throw and not in the control flow. So they are very accurate, and yeah, they're definitely using the low-level CPU instructions, and they like treat that very importantly. So talking about the ecosystem. So from one side, the ecosystem and infrastructure is very huge. So they have a lot of learning resources, how to do proper trading in C++. There are some SDKs, there are some libraries, there is CUDA, there is Quantlib library, which is open source, so you can learn a lot. But the thing is that there is a high cost of moving to a new technology, because your software might be very sensitive to that movement. And also you might affect the clients. If you know the story about how the modulus proposal was changed, the thing was that Bloomberg actually entered the discussion and said that like, no, we can't accept that, because the first version of modulus required from them to change the client's code. And they can't afford that. Like, they have the high cost of this code, they have like thousands of clients around the world. They can't do that. So they need modulus that won't call them to change the client's code. And that's why they actually entered the discussion, stopped it several years ago, and started it from scratch with Richard Smith. Yeah. Now embedded, my favorite area. Talking about embedded here, I'm actually not talking about this nice device. So I'm talking about those who work professionally in the area, those who do self-driving cars, IoT, all the like systems, not those who play with like Arduino devices at home. Okay. I would say that about the embedded, we currently know a lot because we started moving to embedded area with our tools, and we conducted a separate embedded survey, embedded research, just a year ago. So we have lots of data about the embedded. And so we identified the most popular MCUs, vendors, and the areas for embedded. So the thing here is that, again, they have some language choices here. So they have like C and C++, they have some scripting in Python and Lua. The thing is that they do have vendor-specific compilers, debugging tools, testing tools, certification tools. And that makes really hard to move to a new standard, because you can move to the new standard only if your SDK provider or your compiler provider or your debugger provider actually move to a new standard. And you can move, maybe all these nice guys move to a new standard, but your certification tool still doesn't accept that. You can't do that. You can't do a self-driving car that doesn't pass through an official certification. That's impossible. So all their tools are very specific. They are locked to a vendor a lot, and this actually makes a difficulty here, because you actually can't come to this market with just a nice software. No one cares about that. They cares about the integration with the vendors, about how the vendors do treat this software. Yeah, and I would say that actually vendors, compilers, they do live their separate life. They are sometimes not compatible with the standard ones. They cost a lot, and there's like different world of embedded compilers. Yeah, so C++ usages. So when I was doing embedded, I was doing this crazy stuff with structs, with function pointers. That's how we do there, how we deal there. So emulating classes in pure C. This is a world we have to run away from, but we can't, mostly because MCU vendors still do provide their specification for the chips, having lots of examples with all these macros. All these macros HAL is still in their documentation, and you still have to deal with that because you can't work with the MCU if you're not following this official document from the vendor. And I saw many crazy stories with these macros when I was working in embedded. We did actually a network board, and we saw for like maybe a year, we saw an error with some Ethernet interface, and we were trying to guess what was the issue. And then the vendor, by mistake, because there was some Indian vendor, they mailed us the sources by mistake, because they actually added to the email not just the binary that was compiled, but the whole folder. And we found there this define test interface Ethernet 5. We were guessing for 1 year why the Ethernet 5 is not working there, because that was just defined internally for the board like some testing interface. And they just forgot about this macro when they were actually delivering the software. And so all this macro HAL is still there, and I saw many modern MCU descriptions with all these macros which are describing how to work with registers and all this stuff. And that's actually difficult, like you can't overcome that easily. I know that many people in the embedded area currently try to do something with that. I know like fantastic Dan Sachs, who is struggling with all these things and trying to push people to C++. I know Michael Chase from Sierra Consulting, who is pushing embedded people to C++. I know like fantastic Odin Holmes, who is doing meta programming in embedded. Like he's amazing, but not many people actually get what he's doing there. But like, yeah, this is how we should be doing the embedded, but we're still not. Yeah, fun area. I haven't seen any arms here from the games, but it's really fun. We started digging into games area quite recently with some tools, and we found so many nice things in how the C++ is used there. So the games is actually very obvious. There's a very obvious language choice. If you would like to start a game quickly, if you're indie game studio, you just take Unity, throw everything you have into one folder, shake it, and you get a game. That's the Unity games. That's very easy, very straightforward. That's one of the most popular game engine in the world with high rates, and most of the games you see actually is done on Unity. If you do a AAA, which is the biggest, the most expensive, the most coolest games in the world, this is C++, totally. There is nothing except C++ in AAA. One of the most known engine there is Unreal Engine, which is the main competitor for Unity. That's the not biggest part of the AAA, actually. But they earn more than Unity, just because AAA is very expensive. And both Unity and Unreal Engine, they have these policies that you can start using them for free, but when you start earning money with the game, you pay them some rate. And since AAA is very expensive, Unreal Engine gets to the Unity rates quite easily with just a few games. There is also like Lumberyard, which is the CryEngine rebranded by Amazon, and some custom in-house engines, which are the most... Actually, custom in-house engines in C++ is the biggest part of this C++ AAA. But we know nothing about them because that's like, you can guess, that's the biggest treasure for the company. They tell nothing about their engine. They completely store it under some privacy checks. And I know some funny stories like King.com, which is doing this, you probably heard this Candy Crush game, one of the most expensive game in the world now. And Blizzard actually bought King.com just because of the engine. They actually told them, like, you can do whatever you want with your Candy Crush and other games, we just need your engine. So they just bought them because of the C++ engine. That's how the deals go in games development in AAA. So yeah, and rendering is mostly in C, and there's also all these console SDKs provided in binaries, and that makes it actually much harder to upgrade, because when you upgrade into a new standard, you have to push all these like Xbox and PlayStation guys to update their binaries and to provide you then SDK with support to the new standard. And yeah, again, the performance here, the latency, we'll talk about it in more details. So C++ usage, they're mostly on pre-11 and 11 standards. They not using Astel or Boost, and they know now usage for exceptions and the minimal template usage, and they have good reasons for that. So reflection, which is still not in the standard, is the most anticipated feature for the game developers. All the game developers in the world are waiting for C++ reflection. The reason is that they all need it, they all implement it, and they all have their custom implementation for reflection. They just need something standard. Allocators, that's the reason not to use the STL. We'll talk about it a little bit in more details in a minute. So all their memory allocations are custom. So they are not using STL because of the STL allocations, and not an easy way to provide a custom allocator to STL, because they need it to be the part of the type. And yeah, templates, just because they need to reduce the compilation speed. Reflection, just a few words about it. So it's used for several things, naturally serialization, but for serialization you can actually live with just introspection, so you probably know that reflection is introspection plus code generation. So for serialization, you mostly, introspection is enough, but sometimes you still need some code generation, garbage collection, network replication, and just adding various characteristics to the game objects. Yeah, just a few words about Unreal Engine and reflection, because that's a very funny reflection implementation. We know that because the engine is open sourced. You can look at it. Their reflection system is implemented in macros. If you took the picture on the right, you see this U class and U property. These are macros, which are called reflection macros. They're introducing reflection to the classes and functions which are going under them. So they have, in Unreal Engine, they have C++ part and they have blueprint part, which is like you can write a simple part of the game in the blueprint scripting. And this blueprint properties actually shows how the C++ object interacts with the blueprint objects. And so you can like put different specifiers there, providing information about what it is, how it works, how it interacts with the blueprint, how it's collected in the garbage collection. Yeah. Yeah, so all these macros are handled on a preprocessor step. And the awful part is that inside this macro, there is a line macro. And this is a real help for all the tools, because if you type on the top level, everything just gets red until you run the Unreal Engine header build tool, which generate this .generated.h header, which includes all the generated information after the reflection. And there are some crazy rules that this generated.h header should be the last in the list of includes, otherwise everything just breaks. So there's a lot of things that you have to keep in your mind. And yeah, there is another example here is that they have RPC methods, remote procedure calls, and they also implement them providing these reflection specifiers. So when you have these with validation specifiers in a reflection macros, that means that you have actually several implementations with some particular names. And when you're trying to navigate to this implementation in the standard tooling, you never get there. Because no standard tooling knows that it has to go for this server equip weapon, it has to go to the method server equip implementation or server equip weapon validate. That's some additional knowledge that actually comes from the Unreal Engine. Yeah, so talking about the allocation and STL, so as I promised. So no STL, custom structures, plain array is the best structure. And so the problem with the allocators is that they are not using the standard allocators. They allocate in a different way. They are trying not to use heap. So they are trying to use some static buffers. And like this example of in-place array from Ubisoft is actually, like they know that most objects that will use this data structure is of size 8 or smaller. So they just allocate the static buffer of size 8. And if it's bigger, then they reallocate to the heap. But that's a rare case. So they have these special structures. They were trying to use standard allocators. They didn't fit them because they need them to be the part of the type. They don't want to push this across the whole code. And actually, that's why they created in Electronic Arts. They came with ESTL, Electronic Arts Standard Template Library. That's the standard template library for game developers. It has the similar containers, and it has some additional specific containers. That's an open source library. There is a documentation available. And there was a talk from Scott Wardle from Electronic Arts at CPPCon in 2015 about this library. And also there was a talk by Nicolas Fleury also at CPPCon a year before about how the Ubisoft works with the STL and like how do they create their custom STL and how they do create their custom containers. Yeah, so that's their life. So they don't see actually big sense in moving to a new standard because they need the reflection that is still not there, and they're not using STL with all the changes we introduced there. Yeah. Yeah, I know. As I asked them if you're gonna use them, they say like, we'll try. I'm not sure. Like, I don't know. I haven't heard if they really started using that. So I haven't seen any real usage, but I can't be sure because there are still some custom engines. So maybe they're using some features from like this new thing from C++17 regarding the allocation. But since most of them are already have the custom standard library, I doubt they will be moving quite quickly because there are no big reasons for them. We still need to introduce some bigger reasons why to move to the standard containers. Yeah, so these were two biggest areas for C++. Now just a few words about when you move to a new standard, there are a few things important. You have to be sure that you haven't broken anything. And there are a few techniques to check that. Obviously, unit testing. And the things that actually frightens me regarding the unit testing is that we did that question in the survey for several years in a row, and there are still quite many people not using any unit testing framework at all. So for 2019, the green column, it was like 25%. These people are very hard to move to the new standard. Yeah, so, and obviously like the popular standards, they're represented here. And yeah, the thing is that if you ask internet, like what unit testing framework to use with C++, you'll get 3 quite obvious options like Google Test, Boost Test, maybe Catch or something like that. So there are lots of frameworks listed on Wikipedia, like 70. Yeah, and still 25% of the people not using anything from this list. Reddit discussions, very long threads discussing what to use Google Test or Boost. And the general recommendation is actually to use Google Test with Google Mock or Catch. And how the people actually explain that is like, if you have, as they call it, a serious project, use the Google Test. But just be accurate, because Google Test is not that easy to start to use, because it's not recommended to take the precompiled binary, and there is no header-only way to include the Google Test. You have to take the whole Google Test framework and compile it with your project to avoid some conflicts with the compilation flags. Boost test, heavily templated, so if you use it as a header only, your compilation time increases dramatically. So header only is good, but not in the case of the boost test, probably. And in that sense, Catch is fine. It's header only. You just need to include catch.h, and that's it. Somehow the people still don't believe in Catch as in a professional framework. Maybe because that's too young. Like, it was created by Phil Nash, and he started it several years ago. So maybe it's just too young to be ready for people to call it professional unit testing framework. But at least it's easier to start, because we got so many questions from our users on how do I include the Google Test into my project, and they don't know how to do that. Yeah, and just a scary example from embedded world. There are even more people not using any unit testing framework, but that's not scary if you actually dig deeper, because they are not using the unit testing, but they're doing some functional tests, and they're doing some other type of certification tests. So just the regular unit testing, they're mostly not using that, like from 80 to 90%. Code analysis and guideline enforcement. So let's see the numbers. So the good thing is that like just 30% not using any code analysis or guideline enforcement tools, but 42% actually uses what their tooling, what their IDE provides to them, which makes my job much easier. I just need to provide a proper tool for the users, they will use it. But yeah, they just rely on the tooling, and that's somehow under tooling responsibility to provide proper static analysis tools and guideline enforcement tools inside them. So, and like quite obviously, Clang is very popular, like Clang Analyzer, Clang Tidy, CPP check, like a little bit decreasing, and all the others are quite down. And I haven't included here those who got less than 3%. There are quite many actually. And yeah, there was some scary story that at my user group when we were talking about static analysis and all this guideline enforcement, the people in the user group told me like, I don't want the static analysis in my tool. I want it to run in my CI once per week and send me reports on Friday evening. I said like, and what's next? You'll forget about it until the Monday morning. You'll never fix it. So I'm a person who really think that we should push the static analysis and guideline enforcements on people. And if they see them in the editor, they will probably fix that. Because if you get something from CI once per week, come on, no one will fix that. The last part, very short. How C++ committee and tooling actually can help there. There are just some fruits I have in my mind. And so I think that to help the transition to the new standard, compatibility and reduced cost of the integration is very important. So you can see the Modulus as an example here with the redesign after the Bloomberg entrance. And like exception proposal, which is pushed currently by Herbsato. I really like how the proposal is written because it covers the question of how we will deal with the old exceptions, with the new exceptions, how we interact between them, how we match them. And that actually makes me think that this proposal is much more valuable than others one because it actually cares about the transition and also cares about the interaction with other languages like C and Rust, who also can throw some exceptions. Yeah, and regarding the tooling, so definitely we need compilers adopting the features quickly because unless your compiler is supporting the features, you can't start using it. That's obvious. IDEs, they need to provide support for features as well. And here the features actually needs to be toolable. And that's the thing that I spent probably 2 years explaining to the C++ community from the tooling part, that the features that are not toolable nicely, it's very hard to implement them. And now it's good that the C++ community is actually thinking about the toolability, and they have tooling working group which actually cares about that. And probably that will help us to get to this point. And just the last demo, so how the nice feature can be toolable. This is how you get it in the Visual Studio. So template IntelliSense, it was a little bit changed in the recent version. So when you have a template body in Visual Studio, you can actually provide the types which you will be using to instantiate the template. And now they even have the option just include all the instantiations from my code, which is nice because you probably just instantiation the template with a couple of types, and it's nice to know what are they while you're implementing the template body, because you just need some completion or something, and it's just based on that. Yeah, so we do something very similar in ReSharper C++ in terms of supporting the feature. So yeah, that was just example. This is the slide that I promised with the references. So if you'd like to listen to some talks I mentioned here, or to see the developer ecosystem results, just take a picture and go to the link. And I guess the slides will be available. So yeah, you can just explore these things. And if you have maybe 1 or 2 questions, we still can cover them. Or you can just come to me later. I'm still here. Everyone is busy with taking a photo of the slide. Okay, any questions? Okay, then okay, yeah. We do have some statistics. It's not presented here, so it's kind of known facts, like because many companies and many resources that do this kind of service usually collect this popularity. So you probably know that C++ is back growing, and it's somewhere on top. It depends on the source which collects the survey. So it's usually in like top 3, 5, 7. So it's somewhere on top, and that's mostly because after C++ 11 was introduced, there was some like renovation for the language. So yeah, that's kind of known fact. Like C is maybe not growing, but it still stays because it still has its niche. Like, but yeah, the C++ is kind of growing. Yeah. We do plan to go into embedded with some of the tools we have. So in particular, we do plan to do some embedded stuff in C-line. We're currently in the very beginning, we're just exploring the area. So yeah, but that's what we want to do. We can't replace the existing vendors. We can only work and collaborate with them and integrate with them. Yeah. Yes? Yeah, why not? Like, as I said, we're just in the very beginning. We're just trying to, to do some general stuff and then come to the list of features we have to implement. So yeah, you can throw us a feature request as usual. Okay, so thank you. If you have more questions, just come later.